Hello students, welcome to Uncle. Good evening to all.
Good evening, sir.
Good evening. What is the binding energy of hydrogen atom?
Minus 13.6 c square.
This much. So it means the mass of hydrogen will be E is equal to mc square. So E by c square. No? This will be the mass of hydrogen. So now binding energy it is given by sum of masses of products minus mass of the parent one. Okay, so hydrogen it consists of proton and electron. So binding energy will be equal to this into c square. Is it okay?
Yes, sir.
So binding energy by c square will be this. So mass of hydrogen atom will be mp plus me minus binding energy by c square. No? This is not mass of hydrogen, binding energy by c square simply. So it will be mp plus me. It will become plus now. Please check.
Yes, sir.
सर मैंने एक बार आपसे यही पूछा था एनर्जी का, तो आप बोल रहे थे ग्राउंड स्टेट एनर्जी, तो उसको पॉजिटिव लेंगे, तब आपने आंसर वो बी वाला बताया था।
मैं वही सोच रहा हूँ उसमें, वही चीज मैं भी सोच रहा हूँ।
और सर अभी आपने माइनस कर दिया उसको, तो प्लस हो गया।
लेट मी थिंक, एक चीज मुझे सोचने दो। नहीं, वो प्रॉब्लम हो जाएगा ना। प्रॉब्लम क्या है, ये इसमें खुद से माइनस दे रखा है उन्होंने ना। प्रॉब्लम ये है, शायद मैंने ये ध्यान नहीं दिया होगा उस टाइम।
सर तब भी यही क्वेश्चन था ना सेम।
हाँ, तो मैंने शायद ध्यान ना दिया हो इस इन्फॉर्मेशन पे। प्रॉब्लम ये क्रिएट कर रहा है, इसलिए हमें नेगेटिव ही लेना पड़ेगा। वी कैन नॉट टेक इट टू बी पॉजिटिव ना।
यस सर, तब भी मैंने वही आंसर सी दिया था, तो आपने तब रंग कर दिया था, बी बताया था।
कोई बात नहीं, हो जाती है। ठीक है। यस
यस बाइंडिंग एनर्जी को पॉजिटिव लेना चाहिए ना, क्योंकि हमारे पास नेगेटिव ऑफ टोटल एनर्जी होती है बाइंडिंग में।
नहीं ना, बट प्रॉब्लम वही है। नहीं, अच्छा बाइंडिंग नहीं दी उसमें, ग्राउंड स्टेट की दी है।
यस सर, वही तो पॉजिटिव लेना चाहिए, बिकॉज़ वो तो टोटल एनर्जी है, पोटेंशियल एनर्जी है, मतलब अट्रैक्शन हो रहा है, तो इससे नेगेटिव है, पॉजिटिव होना चाहिए।
वही देख रहा हूं मैं, तभी तो रिटर्न मैंने बताया होगा, तो ऐसे नहीं है कि गलत कर दिया हो। सोच रहा हूं मैं, ये ग्राउंड स्टेट की बोला उसने, बाइंडिंग एनर्जी नहीं बोला है।
ये सर तो बाइंडिंग एनर्जी पॉजिटिव हो जाएगी ना।
तो वो ठीक है, मैंने अभी गड़बड़ कर रहा हूं। ठीक है, वो चीज ये बी ही बनेगा। मैं सोच रहा था बाइंडिंग एनर्जी नेगेटिव दे दी है।
यस सर, वही तो मैं कंफ्यूज हो रही थी।
नहीं नहीं, ये बी ही है, बिल्कुल ठीक बताया तभी।
ओके,
तो मैंने देखा नहीं ना, एनर्जी उसमें रेस्ट मास सिर्फ बोला ग्राउंड स्टेट में, तो वो तो बाइंडिंग एनर्जी तो हम पॉजिटिव ही लेंगे। यस, तो यही बनेगा। आई थिंक सी करा था एक और स्टूडेंट ने। किसने करा था? अबे ने करा। अबे क्लियर?
ये तो क्लियर हो गया।
तो वो एक्चुअली जो बाइंडिंग एनर्जी होता है, अगर आपने कॉन्सेप्ट ध्यान से पढ़ा हो, तो वो आप लेते इस तरह से बाइंडिंग एनर्जी को, या ज्यादा वाले में से कम वाली माइनस करते हैं ना हमेशा, तो वो तो पॉजिटिव ही रहेगा। इसलिए उसको पॉजिटिव लेना पड़ेगा, उसको नेगेटिव नहीं ले सकते। बट क्वेश्चन में ध्यान से पढ़ लेना, जैसे इसमें था कि बाइंडिंग एनर्जी खुद से नेगेटिव तो नहीं दे रहे, तो उस चीज का बस ध्यान रखना। अभी इसमें भी अगर बाइंडिंग एनर्जी बोला होता उन्होंने, तो फिर मुझे ये करना पड़ता।
ये सर तब नेगेटिव ही लेते उसको।
तो ये देखिए, तो पार्टिकल में बॉक्स लाइक प्रॉब्लम हो गया ये। But again, there is one problem with this question. It is given that neutron is moving inside a cubical box, but they have not mentioned about the energy state of the neutron, whether it is the ground state or something else. So in such a case, तो आपको ground लेना पड़ेगा in such a case. But otherwise it may be in some excited state also ना.
Yes sir.
तो mention करना चाहिए ना, but आप ground state करिए इसमें. So if we go by the ground state in such a case, if you remember the formula, then the energy is given by this relation ना. Remember this formula?
Yes sir.
Yes, sir.
Yes, sir.
तो ground state तो 1 1 1 होगा.
Yes, sir.
Because neither of these can be 0 ना. The least value they can have is 1. So now we need to solve this. जूल में आएगा ना?
Yes, sir. We have to divide it by 1.6 in 10
No,
to
no,
minus 9.
it is already given. 1 MeV equal to this.
Okay.
So we will divide by 10 to the minus 13 only. So try to solve this and tell me what you are getting. All these will get cancelled. Na? How much?
सर 14.78 मेगा इलेक्ट्रॉन वोल्ट।
तो फिर तो बहुत दूर
Yes,
जा
sir,
रहा है, तो सी ऑप्शन लगाना पड़ेगा फिर तो।
सर ग्राउंड स्टेट 14 है तो सर 14 से ऊपर होगा ना आंसर, तो ये आंसर बट
नहीं एस्टीमेट बोल रहा है तो फिर हाँ बाकी ऑप्शन सारी कम है तो ए के लिए जाना पड़ेगा। कितना है?
Yes, sir. 14.78.
हाँ तो 14.78। अच्छा बाकी सारी कम है तो फिर तो ये क्रॉस होगी ना, फिर ठीक है, फिर ये आ जाएगा और कोई ऑप्शन नहीं बची, बट फिर भी बहुत दूर आया आंसर। इसका मतलब न्यूट्रॉन किसी ना किसी एक्साइटेड स्टेट में बैठा है, इट मींस so we can get the idea in which excited state it would be. Can you tell me the value, this value? How much? So that I can tell you the
4.92.
okay 5 so now.
सर 112 सेकंड कैसे होगा सर?
No 112 many 223. It is in 223. 223 232 322 this state you can check. You will get round about 80 ml. Check and tell me.
83.82.
हाँ
Yes, sir. लगभग same ही है.
हाँ तो actually we are not getting this 16 now, it is becoming 17. So if we get a factor of 16 then we can get that exact value. So we cannot make it to be 16 by integers. So that's why I have taken 223 and sum of their squares it is becoming 17.
Yes, sir.
Clear?
Yes, sir.
So this can be asked in the exam that the energy of the neutron it is this. So tell us about the excited state and the degeneracy also. They can ask you about the degeneracy of that state. So what is the degeneracy of this state?
3.
Yes. And what is the formula to calculate degeneracy?
N plus 1 into n plus 2 divided by 2.
No, it's not like that.
नो सर इसमें
Count the numbers.
factorial
There are
होगा।
3 numbers. 1, 2, 3 numbers. Factorial of that. And how many numbers they are getting repeated? Only one number is getting repeated twice. No? 2 is getting repeated twice, so it is 2 factorial. So this 2 is the number of times a letter is repeated. So if 2, 2, 3, 3 is there, even then I will go with this answer. Okay. So this is not the factorial of this number which is getting repeated. It is the factorial of the number of times it is getting repeated. Okay. So this is the shortcut formula, and you will end up getting 3. Clear? In
Yes,
fact, all the states in which one, if you can say one variable is getting repeated, they will be having degeneracy 3, and all the states having all the digits getting repeated, for example, 1, they are non-degenerate, and all the states with different numbers, they have degeneracy 6. Okay.
Yes, sir.
This one is also different and tricky question. Very quick, Rita, very good. Yes, Durga, Arun. No, Abe. Yes, Ramdiyal. See. So it is given that it is getting divided into 2 nuclei of same masses. Okay. So this is binding energy per nucleon. Now what will be the binding?
Has sir left?
I think so.
Hey, can anybody clear me a thing? Hello.
Yeah, we're listening.
In the previous question, in the second question, we counted for the ground state energy, and then eventually we went up on to 223. But here it is a cubical box. Don't you think we should consider also for 222? And what was the topic I left at that moment? Then we again started discussing the degeneracy. Can you tell me the topic where we just finished 14.78, and after that, what has told to us?
14.78 was the ground state energy, right? And
Yes, yes.
so that implies that the particle cannot have more energy less than 14.78, right? It's the lowest possible
Yes, yes.
energy. So it can have only greater than
Yes,
that.
sir.
So we went to 80 megahertz from Volt as the answer. But Sir told us that if it's possible, there's a possibility of question that given this energy, that the neutron possesses. Sir is starting.
Sorry for the interruption. So actually lights went off at my home. So we were discussing this question.
Yes, sir.
Yes, sir.
So a nucleus with mass number 180 is getting divided into two nuclei of equal masses. Okay. And now have a look at this histogram. This is binding energy per nucleon. Okay. So now what is the binding energy of the product? See here. 90, it falls here, no? Somewhere here. So binding energy per nuclei, it is 6. And what is the mass number? How many of them are there? 19. So it will be 90 into 6. Am I right?
Yes, sir.
But this is for one nucleus. No? There are two of them, no? With mass number 90 each. So what is the total? 1080. Is it clear?
Yes, sir.
And what is the binding energy of original nucleus? Its mass number is 180. So it falls here. And for this, it is equal to 4. No? Okay, so now calculate the difference. So it will be 360. No? 360. So it is energy absorbed or released?
Released because
Why?
there are fission.
Yes. Please check everyone.
Yes, sir.
This is the main information. Half-life you need to calculate. It means you need to calculate lambda.
सर मैसेज नहीं जा रहा है इनबॉक्स में
Message, but Kapil is sending me the message. Is there any problem like this with the anyone else?
नहीं जा रहा है
ऐसा तो कोई कुछ है नहीं इसमें करो. Then how can Kapil send the message? Yeah, Jeshli also sent me the message. Now I got from Durga also. Let me see if yes, Kapil, Jeshli, Durga. So I got 3 messages. It is decreased to 75% of initial value. 3/4. So A is equal to A naught e power minus lambda t. Na? Or either you can go directly for this. This will get converted into this form. Na?
Yes, sir.
Yes,
So this will be 1/30 log of A naught, 75%. 75 by 100 of A naught. 4/3. Please tell me the value of this one.
सर गिवन है ना log natural 4 1.4.
हम वो सॉल्व करके बताइए. चलो मैं करूं.
0.3 सर
Log 4 log 3. So 1/30. 1.4 minus 1.1. 0.3 by 30. So 1 by 100. Na? So 0.693 by 100 days. So 69.3 days then. So approximately it is. हाँ जी.
100 से मल्टीप्लाई करना होगा, डिवाइड कर दिया. ठीक आपने सर
वो लिखने में ठीक है. यहाँ 1/100 लिखना था एक्चुअली. थैंक यू. That was 1/100. Clear?
Yes, sir.
Easy one. Yes, Durga. Kapil, it's wrong.
बी सर
सर मैसेज सेंड नहीं हो रहा सर
एरर नहीं कर रहा है सर
Check
सर ऑप्शन बी
connection. Then I cannot do anything in this. One minute, let me check.
Yes, sir. मैसेज नहीं जा रहा.
Q2 6 by 4.
सर ऑप्शन
बी
बी
आंसर होगा सर.
B
1.5.
option. B option. Yes. So Aditya, Durga, Kapil, it's correct. What is the relation actually? This, na? So if I take the ratio, it will be A1 to A2 cube root. So it will be 216 by 64 cube root, and this will be 6 cube. Please check. So yes, Yashri. So again, based on yes. Half-life is given. So we can get lambda from the given half-life. Log natural 2 is also 0.693, na?
यस सर कट जाएगा
1 by 2. This much. And we know that activity is lambda time n, na?
यस सर
So how to get that n? It's 10 gram में निकालना
10 gram and 3
10
into 6.3.
3 into Avogadro. So solve for this now. इसको भी वैसे 6 ही ले सकते हैं approximately because the options are according to that. So you will be getting 5 point something now. अगर 6 लें तो कट जाएगा 15 5. So 5 point something into 10 for 14. Please check how much you are getting.
फाइव पॉइंट जीरो वन नाइन
So D is the answer. So binding energy per nucleon curve is again given, but now it is in its original form. So two reactions are given, and we have to check which one is allowed and which one is forbidden.
सर मैसेज सेंड नहीं हो रहा
I don't know what is the problem today. Yes, sir, very good. कुछ स्टूडेंट सेंड कर पा रहे हैं, कुछ नहीं कर पा रहे. प्रॉब्लम ये है कि अगर मैं कट करके ज्वाइन करूंगा तो फिर वो लॉस ही ना हो जाए डेटा. यस यशवी कॉल तो बट भाई ये स्टॉप शेयर से तो कुछ फर्क पड़ेगा. लेट मी चेक वंस अगेन.
सर ऑप्शन सी
Yes, option C is the answer. Those who are not able to send, they can speak, okay? So option C is the answer. But after some time, okay? Otherwise, everyone will be able to hear that. And so
Yes,
now see, in first reaction, lead is getting formed 80. So यहाँ पे तो कोई problem नहीं है. This is same, okay? So we need not check this. It is all about this. So in one of the reactions, we are getting 10 proton and 22 neutron. So first of all, let us balance the charge. This is 0 and 1, neutron. 22, 32, 238, and 82. So charge is getting balanced.
And mass is also conserved.
Yeah, mass and the charge both are balanced. And here, 8 2s are 16, minus 1 is 0. How many protons are 16? Electrons are 6, so 10. This may be charge is getting balanced. And in this also, both are getting balanced.
Yes, sir.
चार्ज भी बैलेंस हो रहा है ना, 2 हीलियम 4, 2 प्रोटॉन्स, 16 10, हाँ तो बैलेंस हो रहा है, रिएक्शंस में तो कोई गड़बड़ नहीं है एज सच। और ये तो दोनों ही अलाउड बन रही है, ठीक कैसे बोल, वन में तो फॉरबिडन का कोई चांस ही नहीं, वन कैसे फिर फॉरबिडन है अगर हम there is only one reason for one to be forbidden, because it is not possible to emit so many protons and neutrons. That is the only possibility we are having over here. Otherwise तो
So you said that uranium is radioactive in nature, and when a radioactive nucleus disintegrates, it has to emit alpha, beta, gamma, something.
yes that's what I'm saying, na? That's what I'm coming to that point only. So there is only one reason for this being forbidden, because charge and mass is conserved in both the reactions. So charge and mass is conserved in both 1 and 2 and 1 and 2, but in reaction 1 only protons and neutrons are being emitted and no alpha beta gamma is there. But a radioactive nucleus should emit either of these, na? Either of these rays, oblique particles, you can say. So one is forbidden. That's why it is C option. One is forbidden. Two is of course allowed. That is the only reason. So very tricky one. No use of the graph even.
Yes, sir.
Let us check another one. After this. So we have to estimate the energy of the electron inside the nucleus. This you can remember also. That's why we say, na, electron, it cannot exist inside the nucleus. You might have studied this thing.
Yes, sir.
Yes, sir.
And this 10 to minus 15 meter is in fact the size of the nucleus. Na? That is the standard one that they have provided.
B sir.
Yes, sir. Option B.
And how will you calculate this energy?
सर E equal E square equal to P square C square plus N square C par 4 से P निकालेंगे डेल्टा P डेल्टा S equal to H upon 2 pi तो C से सर
हाँ वो ले सकते हैं बिल्कुल, अनसर्टेनिटी प्रिंसिपल विल कम इनटू प्ले। डेल्टा एक्स आप इसके इक्वल ले लेंगे और पी को डेल्टा पी के इक्वल।
यस सर
इज देयर एनी नीड टू सॉल्व दिस?
No, sir.
Next one, let me check. There are lots of problems on radioactivity actually. A particular radioisotope Yes, Aditya, Kapil, Duda.
87%.
Yes, Arun. Therefore, probability of decay. This na. So in percentage, it will be 7/8. And how much you are getting? 87.5. Please check.
Yes, sir.
BC, sir.
What about others? Only one answer so far. Arun has given me the answer.
BC, sir.
Why D is not correct? Arun, you are forgetting one thing. There are two kinds of beta decay, first of all.
Yes, sir. Beta plus or beta minus.
तो दोनों में से कोई भी नहीं होगा अगर रेशियो स्मॉल होगी.
Okay.
What
Yeah,
answer?
what? तो सोच बस.
एक में in one of the beta decay, proton is getting converted to neutron and in other neutron is getting converted to proton.
जी sir.
So if one of them will be large, it will get converted to other, na?
Yes, sir.
So this is wrong, na? This can occur even when this ratio is small.
Okay, sir.
Yes, sir.
These two are definitely correct. Nuclear matter and nuclear charge are distributed identically in a nuclear volume. So this is again a wrong option, na? Okay. And for option B, nuclei with Z greater than 83, that is uranium, you can think of 82 is the atomic number. Na? They are radioactive and of course they emit alpha radiation. So this is correct. Okay. And surface contribution, it is proportional to the radius square, and radius is proportional to cube root of mass number. So R square will be proportional to A power 2 by 3. Okay. So both B and C, they are correct. Clear?
Yes, sir.
Please check everyone.
Yes, sir.
So they are connecting this to de Broglie wavelength in picometers. This is the reaction. So when does this reaction is possible?
Energy okay no
किसकी एनर्जी?
proton का सर electron
What is the equation to be obeyed by the energy of the electron or the proton? Okay, let us apply the conservation. This should be equal to kinetic energy of both. Nucleus is of course at rest mass, so I have taken rest mass energy, and of course electron can be moving. So T, these are the kinetic energies, and this is given to be 0, massless. Okay, so EE Mn minus MPC square plus Tn plus P nu. That's it, na? Minus MEC square. Please check. So this is the equation to be obeyed. So if the electron is of minimum energy, then these kinetic energies will be 0. They will be produced at rest.
Yes, sir.
So EE minimum, it will be like Mn minus MPC square minus MEC square. So do you know this? Their masses Mn, MP, etc.
Yes, sir.
So what is the value of this one?
It's 1.000
No,
mass of the neutron.
directly tell me the difference. This complete quantity. And then you can use this relation by using this energy.
0.72 mega electron volt.
0.7. Thank you.
782.
782. Okay. So it will be divided by C square and then square root equal to P. And lambda is H by P. Can I move on to the next slide?
Yes, sir.
So P is little bit lengthy question. Usually now again we need to calculate. Anything given? Nothing.
सर कैसी का मान ले लो 12400 इलेक्ट्रॉन वोल्ट एंगस्ट्रॉम
हाँ वो भी ले सकते हैं, पर अगर सबको याद हो तो ना,
Yes, sir. याद है ना?
then you can take that. यहाँ पे मैं जरूर कर सकता हूँ. It is 0.51 MeV ना. So this I have taken in MeV only. तो इसको भी उसी में कर लेते हैं. What you were saying?
12400 इलेक्ट्रॉन वोल्ट एंगस्ट्रॉम.
वो भी है, एक चीज और करना पड़ेगा मेरे को अभी.
सर नीचे मेगा इलेक्ट्रॉन वोल्ट कॉमन आ जाएगा ना.
हाँ वो आ जाएगा 10 की -6 आएगा एक तो, एंड एंगस्ट्रॉम भी है ना.
Yes,
10 की
sir.
-10 आ जाएगा इतने मीटर. अब बनाइए. So we have to calculate it in pico ना. So 10⁻12 I can take and -4. So this is the quantity in picometer. So you can solve for this and you can get your answer. This is picometer now. And tell me how much you are getting.
सर 2.09.
So this is the final answer.
सर ऑप्शन सी.
Yes. Because radius is directly proportional to a power 1/3, and lambda will also become a power 1/3 like, and P is h by lambda.
Yes, sir.
Can you please repeat?
This na?
Yes, sir.
Okay.
So lambda is approximately equal to R. Yeah, the approximation. Okay.
Yes. Because we have to get the proportionality factor only.
Okay, sir.
Everyone might be knowing the answer. Well-known curve. No?
No, sir, I'm afraid I'm not.
You can see any nuclear physics book, and this is
Sir,
the graph.
Okay, sir.
You can remember the mass number around. No need to write. Okay, Durga, it's partially correct. Again, Kapil partial. Everyone is giving the partial answer. One has given. Yes, Arun, very good. Only Arun has given the. Please think over again. Everyone who has given the answer. Yes, Rita, very good. Aditya, again, please think. Partially correct. Durga, again, you are giving partial answer every time. From where does this relation comes? How do you get this relation? First of all, from the plot, we get this information directly. No?
The center density means the volume density, right? The density of the.
Yes, this is independent. And volume energy per nucleon is also a constant according to this.
yes, sir.
Because it will get cancelled. Na? And this information we are not getting from this anywhere. What about D part? Just think over from where we get this relation, you will get this answer. From the scattering experiments. Na? You might have read this. We get this
Yes,
information from the scattering experiments. And that's why this nuclear force is charge dependent. Okay.
बट सर आपने प्रॉपर्टी लिखाई थी न्यूक्लियर फोर्स की, उसमें चार्ज इंडिपेंडेंट होते हैं न्यूक्लियर फोर्स
होती है, बट ये इंप्लाई ये कर रहा है ना.
ओके
उन्होंने बोला है ये जो इंप्लाई इसके स्कैटरिंग एक्सपेरिमेंट से यू गेट दिस इंफॉर्मेशन, बट एक्चुअली इट इज चार्ज इंडिपेंडेंट. वो तो बाद में आया ना, जब प्रोटॉन 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 न्यूट्रॉन फोर्सेस वो सारी सेम आई लेटर ऑन. Let us see some of the questions from this new question paper 2021. One minute. Yes. Totally different question, but t equal to 0 and not number. UTI A. It's lambda A, not lambda naught. to the leading order. So A goes to B with a decay constant lambda A, and B goes to C with a decay constant lambda B. So B. So we got these relations, na? We secular and transient equilibrium, remember? So this was the equation. And now what is the time? Small time. So we can go for the binomial expansion.
Yes.
So lambda B minus lambda A, again it will get cancelled. This is the leading order term, na? And not lambda A T. The option, na? Please check.
Yes, sir.
Let me check any other question. But every time one question from radioactivity is always there. So that is the important part that you should not miss. No, nothing. Let me check in 2000. So in 2021, only one question was there, and then let me check in 2020. Don't leave the class. I have to see one or two questions from 2020. Okay. Only one question is there, and in the last, let me see. So the question is the radioactive nuclei 40K potassium decay to 40 argon with a half-life of isotopic ratio for a particular rock. So we have to find the ratio, but potassium, it is decaying to argon. So how much potassium will be left? If to start with we are having only potassium, then actually this is the equation. This is the original number. This is the left out number. This is the original one. Okay. So if initial, this is the left out part, and how much of this is formed, and not minus this now. So this is given to be 50. Okay, so and not I can cancel. 50, sorry. Please check up to this point.
Yes, sir.
So from here I can get T, na? Because no, I need to get lambda first, na? Because half-life is given. Or we can substitute lambda as a 0.693 by this half-life. So we have to calculate T, na? 1 by lambda. So lambda will be 0.693 by T half. So now can you solve this? This will directly come in years. Na? So it means that M will be, if I leave a factor of 10 to the power 7, then M will be 125 by 0.693 log of 51 by 50, isn't it? After comparing it with M into 10 to the power 7,
Yes, sir.
So please get me this value.
3.57.
3.57 exact. So this should be the answer. Okay. So that's all for today, students. So these were the questions from nuclear physics part. Okay.
Yes, sir.
Okay, students. Bye bye.
So tomorrow, sir, which part will be taken for the revision?
I think it is. Let me check. Now we are left with the optics. One is optics, no?
Yes, sir.
Yes, sir. And
And
oscillation waves.
oscillations and waves. So I think it is oscillations, waves, and then optics. But let me check the order. 1 minute. It's oscillations, then waves, then optics.
Okay, sir.
Okay. So I'm writing the order for you as well. First oscillations, then waves, then optics. Okay.
Okay, sir.
Bye bye. Take care.
Thank you, sir.
Thank you, sir.